Welcome to this video on static friction, part of our forces series. Static friction is one of the most important forces we encounter in everyday life. It's the force that keeps objects from sliding when they're at rest. Let's explore how it works and why it matters. Static friction is the resistive force that prevents an object from starting to move when a force is applied to it. When you try to push a heavy box across the floor, static friction is what resists your initial push. It acts in the opposite direction to the applied force, keeping the object stationary until the applied force becomes strong enough to overcome it. At the microscopic level, all surfaces have tiny irregularities, even if they look smooth to our eyes. When two surfaces are in contact, these microscopic bumps and valleys interlock with each other. This interlocking creates resistance to sliding motion. The rougher the surface is, the more these irregularities mesh together, creating stronger friction. There are two types of friction between solid surfaces: static and kinetic. Static friction acts on stationary objects and must be overcome to start motion. Kinetic friction, on the other hand, acts on moving objects. An important point to remember is that static friction is generally stronger than kinetic friction. This is why it's harder to start pushing a heavy object than to keep it moving once it's already in motion. The coefficient of static friction, represented by the Greek letter mu subscript s, is a dimensionless value that tells us how much friction exists between two surfaces. It has no units because it's simply a ratio. Different material combinations have different coefficients. For example, rubber on concrete has a high coefficient, while ice on ice has a very low coefficient. This value depends entirely on the surface materials and their texture. The maximum static friction force can be calculated using a simple formula. F sub s comma max equals mu sub s times n here. F sub s comma max is the maximum static friction force, mu sub s is the coefficient of static friction, and n is the normal force. The normal force is the perpendicular force between the two surfaces in contact. This formula tells us the maximum friction force that can exist before the object starts to slide. Static friction is everywhere in our daily lives. Car tires gripping the road without slipping rely on static friction for traction. Our shoes prevent us from sliding on surfaces thanks to static friction between the shoe sole and the ground. Books stay stacked on a table because static friction keeps them from sliding off. Even a ladder resting securely against a wall depends on static friction at both contact points to stay in place safely. Three main factors affect static friction. First, surface materials. Different material combinations produce different amounts of friction. Wood on wood behaves differently than metal on wood. Second, the normal force. Greater weight pressing the surfaces together increases the maximum static friction proportionally. Third, surface texture. Rougher surfaces generally create more friction because their microscopic irregularities interlock more effectively. Let's look at a practical problem. A 50-kilogram box rests on a horizontal surface. The coefficient of static friction between the box and surface is 0.6. The question is, what is the maximum static friction force? To solve this, we need to find the normal force first, then use our friction formula. Here's how we solve the problem. Step 1. Find the normal force. For an object on a horizontal surface, the normal force equals the weight. N equals m times g, which is 50 times 10, giving us 500 newtons. Step 2. Calculate the maximum static friction using our formula. F sub s comma max equals mu sub s times n, which is 0.6 times 500, giving us 300 newtons. Therefore, the maximum static friction force is 300 newtons. Static friction has countless practical applications. In construction, it keeps structures stable and prevents components from sliding. In transportation, it provides vehicle traction and is essential for braking systems to work effectively. In machinery, it prevents unwanted movement in mechanical parts, ensuring safe and reliable operation. In sports, the grip provided by athletic shoes and equipment depends entirely on static friction between surfaces. Let's review the key points. Static friction prevents motion between stationary surfaces by resisting applied forces. The maximum static friction force is calculated as F sub s comma max equals mu sub s times, and static friction is generally stronger than kinetic friction, which is why starting motion requires more force than maintaining it. Finally, static friction depends on both the surface materials and the normal force pressing the surfaces together. Understanding static friction helps us analyze and predict the behavior of objects in countless real-world situations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.